So the high school athletics department is installing a new rectangular addition to their current practice field. The length of the new addition will be at least 10 meters more than twice the width. So this is the width. We don't know what it is. And the length will be at least. So it's going to be greater than or equal to, right? So at least means that there's a lower boundary, so every value above that is valid, right? Like I could say, when I say I'm at least 5 feet tall, well, that means I could be 5 feet, but it also means I could be 6 feet. So when you think about that, that's greater than or equal to. So at least 10 meters more than twice the width. The original field has, so let's label this original, has 300 square meters, and the area of the practice field with the addition must be no more than 1,200. So the area no more than 1,200 means less than or equal to 1,200. Can't go over 1,200. And so I think we have what we need. So let's do a couple things. What is area? Well, the area is just the length times the width. So in this particular case, we have the length, which is 2w plus 10 times w, or 2w squared plus 10w. I gotta reread this question. As I'm thinking, why are they telling us the original field is 300? So let me go back and reread the question, because I don't know if it's important or not, but it says that the high school athletics department is installing a new rectangular addition to their current practice field. The length of the new addition must be at least 10 meters more than twice the width of the new addition. The original field had an area of 300 meters. The area of the practice field with the addition must be no more than 1,200. I think we're tacking on this plus 300, right? Because this plus this is the total, right? So so it says the practice field with the addition. So I think if I were to talk about the area, there's the area of the new plus the original. So this would be plus 300. This would be plus 300. And this would be plus 300. Okay. So we're asked to write two inequalities. And so one thing I know for sure is that the total area, one equality would be the total area is less than or equal to 1,200. And then the second equality I got to figure out what we plug in will be, and they said use x instead of w. I'm going to say 2x squared plus 10x plus 300. Oops. All right, so then the area, it's got to be greater than, because the length is greater than, right? In other words, this length is the lower boundary. So I've got this needs to be greater than that. In other words, this length is actually greater than this. So then if it's greater than this, then the area could be greater or equal to. So this is like, it's weird. When you have a greater than inequality symbol, that's what we call a lower boundary or lower bounds. And so what that means is that my area, this is the limiting factor. It could be lower. This is the lowest it could be, which means it could be higher, right? So when I do all the math, that length that I factored in could be higher or greater. So then my area could be greater than this. And so we would graph these two. And then the solution set would be the values of x that are in the shaded region. So this is technically the answer, which reminds me, on the last problem, I should have multiplied out the area, but it's still the same thing, theoretically speaking. It's still the same answer, theoretically speaking. And that's it.